Next topic of chemical kinetics is gas phase first order reaction. Earlier we have done integrated reactions or integrated form of zero order reaction, first order reaction, then pseudo first order reaction, and finally now gas phase first order reaction. For this gas phase first order reaction, taking a reaction, for example, in which A, which is a gas, it forms products B and C, which are gases, and let partial pressures of these gases A, B and C are taken as PA, PB and PC, and the total pressure is assumed to be or taken as P total or PT. Now if we see here, when reaction starts, then initially at time T0, let the concentration of A, where we have to take here in terms of pressure, that is P or PI, P initial. It means we can say in the starting of the reaction, when time t equal to 0 seconds is taken, then initial pressure of A is taken as Pi. And at that time, reaction has just started, so pressures of B and C are 0. Units of pressure we can take in atmosphere or bars. So let it be atmosphere, so we have taken Pi. At or after decomposition at time t, some parts of A has decomposed. So if it is decomposed, then let the degree of decomposition is X. So B and C, they are formed as X, and from Pi that X amount is removed. Therefore, now at time t, total pressure will be the pressure of A, the pressure of B as well as the pressure of C, their summation. So P total at this time is Pi minus X plus X plus X, that is Pi plus X. These X get cancelled out. So Pt equal to Pi plus X. If we want to find out X, that is equal to Pt minus Pi. Now here this is X, and at time t the partial pressure of A is Pi minus X of the reactant. Reactant A, its partial pressure at time t, Pa equal to Pi minus X. This is the partial pressure Pa, this is Pb, this is Pc for the C. So it means here Pa we know that is equal to Pi minus X. If we put the value of X here, so we'll get Pi minus Pt minus Pi, value we have applied here. So what it will be? This is minus sign, this becomes 2 Pi minus Pt. This is partial pressure of A. Now on putting the value of this in first order reaction, first order equation integrated form, that is K equal to 2.303 upon T log initial concentration of the reactant upon final concentration of the reactant at time t. Here, according to this reaction, we can change it for the gas phase reaction where pressures are taken upon T log. Now, initial concentration. What is the initial concentration? We have supposed Pi, initial pressure of gas phase reaction, and pressure at time T, just we have calculated at time T, pressure of reactant is Pi minus X, and that we have derived as 2 Pi minus Pt for this particular reaction. So this is gas phase first order reaction for this type of reaction where A is forming B and C. That is, for every type of reaction, this derivation will be different. This part will be different. Because if we take the other example, let here A is not A here, 2A is changing into 3B plus C. So this condition will be changed. Initially, the concentration or pressure of A is taken as Pi. So here they are 0. At time t, this is at time t0, this is at time t. This will be Pi minus 2x if degree of dissociation of reactant is x. So here 2x we have to subtract, remove, and here 3x will be formed, here 1x will be formed of C. So due to these stoichiometric constants, these conditions or these concentrations or we can say pressures of these three gases or whatever number of gases are there of reactants and products, they will also change. So finally for this P total, Pt will be Pi minus 2x plus 3x plus x. So here Pt will be different. If Pt will be different, then if we will find out x and we put the value of x, so we will get Pa, that will also be different because here Pa will be Pi minus 2x. Now you have to find out this value Pt, then find out x, then put the value of x in this x and find the Pa, then finally write down first order gas phase reaction, that is K equal to 2.303 upon T log initial pressure is Pi, final you have to find out by using this. Everything is in front of you, you have to find out only.